Welcome to Cosmic Compass, the channel where we explore the wonders of the universe, from the mysteries of distant galaxies to the secrets hidden within our own solar system. Today, we set out on one of humanity's greatest adventures. Together, let's follow the Voyagers, two small probes launched in the late 1970s that defied all expectations and carried us farther than we ever dreamed possible. Nearly half a century later, they are still sending back messages from the edge of interstellar space. What did they find out there? How did they survive against all odds? And what do their journeys mean for us here on Earth? Let's begin. In the summer of 1977, when computers filled entire rooms and the internet was still a dream, NASA launched two small spacecraft on a journey no one truly believed would last very long. They were called Voyager 1 and Voyager 2. Designed to survive just 5 years and study the gas giants, these twin probes were expected to fade into silence before the decade was even out, and yet nearly half a century later, we are still listening. The Voyagers continue to whisper faint signals back to Earth, carrying the legacy of the longest-running space mission in human history. But what did they discover? How did they endure so far beyond their expected lifetimes? And what mysteries of the solar system and beyond did they reveal today? Let's retrace their astonishing journey and uncover the secrets these tireless explorers left behind. Voyager's endurance was no accident. Each probe carried a power source, unlike anything we might expect today, a radioisotope thermoelectric generator converting the heat of decaying plutonium into steady electricity. With no need for sunlight, these probes could venture into the cold, dark reaches of space where solar panels would fail. They also carried backups for most of their 11 instruments and a full set of thrusters, ensuring survival against mechanical failure. But the most critical advantage came not from hardware, but from timing. In 1977, the planets were aligned in a once-in-176-year window, allowing the Voyagers to slingshot from one giant to the next. Each gravity assist boosted their speed without burning a drop of extra fuel. What would otherwise have been an impossible trajectory became not just possible but historic. Voyager 1 arced above the plane of the solar system, climbing north, while Voyager 2 drifted south. And before their cameras were turned off to save precious power, they gave us one final haunting gift: the pale blue dot photograph Earth, seen from 6 billion kilometers away, a reminder of our fragility in the vastness of space. Leaving the outer planets behind was not the end. It was, in fact, only the beginning. To reach true interstellar space, the Voyagers had to cross invisible barriers at the edge of the sun's influence. First came the termination shock, where the supersonic solar wind slammed into the interstellar medium and slowed dramatically. Then came the heliosheath, a turbulent zone of compressed, heated plasma. Finally, they would approach the heliopause, the final frontier separating our sun's bubble from the galaxy beyond. Scientists once imagined these boundaries as smooth and predictable, but Voyager revealed something messier, a frothing region of magnetic bubbles, as if the sun's magnetic field had shattered into countless fragments. The elegant models we once held were replaced by a more chaotic but more truthful picture of our place in space. On July 25, 2012, Voyager 1 became the first human-made object to break free of the heliosphere. Travelling at nearly 540 million kilometres each year, it pierced the heliopause at about 120 astronomical units from the Sun. The instruments recorded exactly what scientists had predicted: an 80-fold increase in plasma density and a surge of cosmic rays. But one finding left them stunned. The magnetic field did not change direction. Models had always assumed that once in interstellar territory, Voyager would detect the influence of other stars. Instead, the magnetic orientation remained the same. Had we really crossed the boundary? Was the probe still inside the sun's domain, NASA hesitated for almost a year before confirming the truth. Voyager 1 had indeed entered interstellar space, but the cosmos beyond was stranger than we had imagined. 6 years later, on November 5th, 2018, Voyager 2 joined its twin. At a slightly slower pace, it too crossed the heliopause at roughly the same distance, 120 astronomical units. This consistency was puzzling. According to our models, the size of the heliosphere should swell and shrink with the Sun's 11-year activity cycle. Yet even at the height of solar wind pressure, Voyager 2's crossing occurred where Voyager 1's had. Once again, the magnetic field remained unchanged. Two probes, two different eras of solar activity, and still the same mystery. The clear-cut boundary between sun and stars proved far more twisted, unstable and unpredictable than our theories allowed. Though their power is dwindling and their instruments shutting down, the Voyagers are not truly at the end. They are only at the beginning of their eternal journeys. In 40,000 years, Voyager 1 will drift past a dim star in the constellation Camelopardalis. Voyager 2 will follow its own lonely path, passing Ross 248 before eventually gliding near Sirius, the brightest star in our night sky. By then, Earth itself may be unrecognizable. Civilizations will rise and fall, continents will shift, and even the memory of who first built these machines may fade. Yet the probes will continue on silent witnesses to a galaxy that will outlive us all. And should they be found, each Voyager carries a golden record, a message written not in words, but in music, sound, and images. On it are greetings in 55 languages, the laughter of children, the songs of whales, the notes of Mozart, and even Chuck Berry. There are photographs of our planet of animals, of human life in all its diversity. It is in essence a time capsule, a declaration that Earth once existed and that humanity reached out into the cosmos with curiosity and hope. For us, it is not just a record of sound, but of identity, a cosmic introduction to whoever may be listening. Soon the Voyagers will fall silent. Their power will fade, their instruments will freeze, and their voices will vanish into the background of the stars, but their legacy endures. They showed us that even fragile machines built by human hands can touch the edge of eternity. They revealed that the universe is not a distant dream, but a place we can visit, study and explore. And as we look to the future, we know this will not be our last encounter with the stars. Voyager was the beginning, the first step on a path that leads far beyond our sun into the uncharted depths of the galaxy. So as we say farewell to these distant travelers, let's remember what they carry, not just instruments and data, but the story of us, of who we are, and of how far we dared to go. And so the story of Voyager continues not just as a mission, but as a symbol of our relentless curiosity. These small, tireless machines will travel for tens of thousands of years, carrying with them a message of who we are long after we are gone. If you enjoyed this journey beyond the sun's reach, don't forget to like, share and subscribe. It helps us continue exploring the cosmos together. Until next time, keep looking up and let's never stop reaching for the stars.